For the retake video, I just want to go through regraphing absolute value equations and then finding the domain and range. I'm also going to show you how to graph these on Desmos. So for this first one, once again, we can make a table, but we talked about we need to make a 0 inside of the parentheses. Well, we're lucky here because there is nothing except the x inside the parentheses, which means that our vertex is probably 0, 0. Okay, so let's check if that ends up being true. So if our vertex ends up being 0, 0, that means the middle of our table can probably be 0. Then we'll go -1, -2 like normal, and then 1 and 2. So if we plug in our equation for -2, I would do -2 times the absolute value of -2. Absolute value of -2 is +2. +2 times -2 is -4, which that one will be right here. For -1, I do -2 times the absolute value of -1. This is 1. 1 times -2 is -2, which is right there. And 0, so I do -2 times 0 is 0. And now let's see if it's actually our vertex. So if I plug in 1, I do -2 times 1 is 1 times -2 is -2, and it looks like that is our vertex. Now this one has a negative value in front of the 2, and it looks like it flipped our graph, which is very normal. If you have a negative value, you're still going to be making a V shape, but it's most likely going to be upside down. Now for our domain and range, domain represents all of the x values. The range represents all of the possible y values. And if we remember the way I remember that from the last video, I said that domain starts with a D. D comes before R in the alphabet. X comes before Y in the alphabet. Now my x values, it looks like the line's going to go on infinitely down this direction. So all of the positive x values will eventually be used. All of the negative values will eventually be used. So this means all possible x values or all real numbers. Remember, all real numbers is definitely the fastest way to say that. The range, though, is restricted a little bit differently. It looks like this is our maximum this time, and none of these values will ever be used up here. So y values are only smaller than 0, which means the y value must be less than or equal to 0. Now let's graph this on Desmos to see if it ends up being correct. So here we are on Desmos, and I'm going to go y equals. Now absolute value, there's two ways to write it. There is a button on your keyboard that looks like this, but if you can't find that button on your keyboard, you can actually do -2 times, and then ABS stands for the absolute value. Close my parentheses, and there is my graph. Now what's really nice about this is I can see what the vertex is just by hovering over it, and clicking on it will show me the vertex. Now I can also, find other ordered pairs on here, but the one I care the most about is right there. So let's graph one more and then check it on Desmos here. This one looks a little bit harder, but if we remember where to start the middle of our table, it's still going to be the same process as before. Now, if you remember, our table wants to start with where the vertex is going to be in the middle, so right here. So what I want to do is I look at, in the parentheses, I want to create a 0 inside of the absolute value bars. So x would have to be -2 to make this value a 0 inside of here. So I'm going to guess that my x value in the middle of my table should be -2. To see if that worked, I still have to make out the whole table, though. So that's what I'm going to do. Okay, so let's start with -4 and plug it into our equation and and see what I get. Now this should be a 1 here. Okay, so we work inside the parentheses first. This is -2. Absolute value of that is +2. Times -1 is -2. -2 plus 6 is +4. Now it's probably going to be easiest to actually write that out like this. -1 times 2 plus 6. But for the sake of time in the video, I am not going to write those out. Plus it's going to take up the whole screen. Okay, so this one is -1. -3 plus 2 plus 6. This ends up being -1. Absolute value of that is +1. -1 plus 6 is 5. Now, if we do this one, we are hoping that it ends up giving us our vertex. This ends up being +6. And then if we plug in the next one, we do end up getting +5 again here, which is what we wanted, which means that this is our vertex. And so let's graph this really quick. And it looks like this is also going to be an upside down equation. Graphing on this app is not super easy, but it works out okay. And I have right here my function. Now, for the domain and range, remembering that our domains are our x values and our range is our y values. Domain here is all of the possible x values, so all real numbers. And our range looks like it maxes out here at +6. Therefore, our y value cannot be bigger than that, so it has to be all y values that are less than or equal to +6. Let's double check this on Desmos to see if it worked. So -1, oops, that's not right. So let's delete our old one. So let's do f of x equals -1 absolute value. If you don't remember the absolute value bars, was it, I think it was x plus 2 and then +6 on the outside. Okay, so x plus 2, there we have that, and then we're going to add 6 on the outside. Our vertex is -2, 6, which is what we had before in our graph, and the graph does look very similar to what we had before. So, as always, if you have any questions, please let me know.